Hi everyone, welcome to our the construct here, the channel Becoming a ROS Developer. My name is Rodrigo, and today we have Paulo here that is going to show us his project that he did for ROS Basics in Python, in which he uses several techniques and programs to communicate with a robot in a simulation and in the real robot that we have here, Turtlebot 3. With the usage of topics, actions, and services. So, hi, Paulo, how are you?
Hello, I'm fine. Thank you. Thank you for having me today.
Oh, great, great. I'm glad to have you here. So, just to let you know, we're just going to do a quick presentation on your project, what you did. Plan around for like 15 minutes, and then afterwards, we'll test. If you want each section, you can do one section and then show us in the project, and that way we can kind of follow along your explanation. And yeah, that's it. So if you want to go ahead and share your screen and or introduce yourself, and we'll get started.
Okay, thank you so much. Hello, everyone. So I believe let's get started, right? So I'll share my screen. I believe you should be seeing everything right now.
Yes, we can see it.
Okay, so the problem that was proposed was, so if we have our turtle, the objective was to have this Turtlebot move in a square around, well, this is not really a square, but like a rectangle around this arena, and at the same time develop an action to publish some feedback on where the robot is at each point, and also track how many meters it has traveled. So starting from the client, what I believe it's in here is pretty regular. We start by instantiating this node. I just said it was anonymous because I don't really care about the name of the node in this case. Then we wait for the service, and in this case, this client is going to call the move square server to move the robot around the arena. So we need to wait for the service and then ask for the service proxy to get the move square service. Then this is related to the actions, which I'll explain a bit later. So what we do is, okay, we're going to send a request to our server, right? In this line, and this request is actually encoded in this moving square file. So it has no parameters, and once it completes, it sends a message saying, okay, it is completed. It went around the arena successfully. So on the other side, we have the move square server. Now, in this case, I prefer to use a class because we need to subscribe to the scanner. We need to have attributes, right? So we need to access to different information at the same time. And so I also am going to publish the velocity so that the robot can move and turn around. We are going to subscribe to scan so we can see more or less, okay, how far am I from a wall. And this is because one of the requirements was, okay, once I get close to a wall, I should stop. And this is a small act that I did, and I am going to explain later. So how does the robot move once our client sends the request? So this is the main callback method that we have. We create a response message, which is by default false, right? And then if it terminates, it's going to be true. So what happens is, okay, so I'm going to have one, two, three, four, five. So I created a map with the distance that it should travel for each side of this rectangle. So for in the first iteration of the cycle, just 6, then 7.5, then 11, then 8.5, and then 6.
Okay.
And so I abstracted these into a method, and after moving, every time after it moves, it needs to turn.
Okay.
And in this case, I have this turn. I've added a 0.39 of frequency because I was trying. So since our rate is 10, I was trying to match, and I'm going to spin for 4 seconds. I was trying to match the rotation, so it is a 90-degree
Right.
angle for rotation. And this is pretty much it. I have a shutdown hook, so it finishes. And okay. Now, this was the first part, which was, okay, move the robot around in a square to the initial point. Then it was also asked to record each point while we're moving. And if for some reason the robot finds a wall, it should stop. Okay, so to have the robot get the points at each step, one point per second, what did we do? In the move square client, we have these lines which correspond to the lines where we're going to make the asynchronous call to the action. So I've defined the record odom action. We're trying to connect to it. We are going to wait for it to turn on, set the goal. And in this case, our goal, we don't have any parameters in here. We are going to have a list of points as what is returned in the end. And if I'm not mistaken, let me just check if this is not, yeah. And has a feedback, we're going to have the total traveled at each point. Okay, so how does this happen in the Odom server? So once again, I have a class. I instantiated the feedback variable that is going to be accumulated and the list of Odoms. The rate is 1, so we're going to be publishing once every second the feedback. And we subscribe to the odometry, so we can know the position of the robot at each time, and so that we can save the point of the robot every second. And I make a calculation to see how much it has traveled. In this case, I had to throttle the subscriber since I only want, so I was receiving thousands of messages from the odometry. So I wanted just to have 1 per second. So what I did was, okay, I'm going to put a self-punch rate on sweep in here.
Right. And you said it was 1 hertz, the rate. So it was once per second. Okay, yeah.
Once per second, here it is.
Okay.
So once it finds a wall, okay, and that's it. Then we have our goal, right? So I'm going to make the result. The result is going to be our list of points that we are percolating. And as a feedback, we're going to publish the total, the current total traveled. Now, there is a data racing problem in here, which I did not solve because we have two different callbacks accessing and writing and reading the same variables at the same time, but in the end, it doesn't make much difference in the robot. Okay, now what happens is when the robot finds a wall, it should stop. The first thought I had was, okay, I'm going to send a request to preempt to stop the action, but then I thought perhaps that's not a good practice. So what I did was, okay, once you find a wall, if while we're moving, I find a wall, then I created a new topic and I sent a message to that topic saying, oh, we found a wall. And then in this place, it checks that we found a wall, and the robot, the action stops successfully. And
okay, so you get a result, like your action completes.
Yeah, and you can get a result. Otherwise, you wouldn't.
Yeah, exactly.
Okay, and that's pretty much it. We can also, in this case, I'm going to launch here the robot in the simulator just to check if it's working all right.
So that main.launch includes the servers for the, what does it include?
This main.launch includes the move turtle square and the record odom server on Pi. And since I already had these done, I already had these two, I simply added it instead of adding the. Okay, so in here we have the points being, okay, so in here we have the distance that it is
it's been traveling, yeah.
Traveling. The 90 degrees, it's not really that proper, to be honest. But perhaps that will be interesting if it gets a wall to see it stop. I hope.
So in this, you did a square that goes around the whole map then. And you did with that map that you showed in the, was it in your server? Yeah. In here. The thing I had the hardest time was really with like the angular position and to check. Okay, so in here he found this wall. Oh, he found an obstacle and it stopped.
On the wall, it terminated. Here are the recorded points.
But you still get the result of the action.
Yeah.
Okay.
Because I didn't stop it as a preemption. I stopped it like, okay, it was successful.
Right. And that way you can get a result from your action and also know that you stopped because you saw a wall.
A wall.
Okay. Okay, that's interesting. Great. Do you want to check if it works in the real robot?
Yeah.
See what happens. We might have an issue with the odometry, but that's a hardware issue that we have right now. So just so you know. Other than that, I mean, it's just nice to see it work in an actual robot.
Okay, let me.
Okay, so we are.
It's working, and right now I'm praying it works.
Oh, don't worry. I mean, it's always like that, you know. There's always new things to see in the real robot, but.
See if I can.
At least we can see if, you know, your client makes the call and it starts moving and, you know, all that fun stuff.
Okay, I think it's
setting it
Good.
in place. Okay, so and what velocity did
Okay.
you set it at? Just wondering.
0.1. Oh no, it's turning the wrong side.
Yeah, it turned on the
Okay, I should put it in here. I should put it in here so it goes like this.
right, but I think it did work. I mean, the
Yeah.
odometry and everything was except
Yeah,
it turned the wrong way. Yeah.
the velocity is 0.1.
Okay.
So because I saw somewhere there was a limit.
Yeah, we
for
have a
it.
limit just so people don't, crash into it too hard. And
Yeah.
since it's available all day, all night, the motors will take a toll, as you might have
Yeah.
seen with that odometry encoder message.
Oh, come on. Okay.
Yeah, sometimes when the motors get forced
Yeah.
too much, it stops for a little bit. But I can actually hear it yelling at me. So let me go really quick and fix it, and we'll try it. And if not, that's okay.
Okay. Mm. Oh no, it didn't work. Okay.
All right.
Okay, let me see if I can set it.
But obviously here you would change the values for that map that you were talking about,
Yeah.
that side. Yeah, yeah.
I'm hoping that this is more or less the same here. More or less here. Okay. Let me just turn it a bit. Okay. Okay. Let's see. Going front. Okay.
All right.
Turn left. Turn left. Not turning.
Hold on.
Okay, it's turning. Oh God.
And in here, it should have
That's
been like,
insane.
oh, I found a wall, no? Because
Yeah.
it's in the middle
No.
of that find a square, or?
Okay, no, now that's the question I want to ask you.
Mm-hmm.
The sensors are on the opposite side, right? Because I've noticed it in the simulator,
Mm-hmm.
the robot moves in front and the sensors are like in front, but in here the sensors are on the back.
Well, what it is the readings of the laser scan in the real robot actually have 720 values.
Oh, okay.
As opposed to as in the simulation
180.
they have 360 actually.
360.
So maybe it's that that in the
For example, if I do it like this, it will show me like I found a wall and it will finish. 1 second. Okay, no.
it's kind of I bet it's looking at to a side, it's like right there. It probably
Really weird.
Yeah, I think it's the issue of the motors that we're having. But Yeah, that's not normal.
It stopped again.
Yeah, it stopped. That's an issue with the motors. But yeah, the main part of it, that's okay. You don't have to. I mean, we saw that it works in the simulation. There are steps to do for the real robot. For example, that readings are different for the sensor.
Yeah.
So that's one thing to take into account when changing to the real robot. And but I mean, in your simulation, it did its job. So that's sort of what we were looking for here. And let me just go ahead, ask you some questions then that I found interesting in your code. So the first thing that I noticed is that you ROSified that in front wall topic, that you created that wall, that topic to make sure to find that, to use it in your action server, if I'm not incorrect. Mm-hmm. Okay, so you would know that the action has been finished, but you have found a wall. So in reality, you didn't complete the entire action that the action server is performing, right? So
yeah.
What is an advantage that you see on this? As opposed, I know you said it's not best practices, as an advantage of doing this as opposed to just canceling the goal that you're sending to the client, the server. I'm sorry.
Well, first off, I'm not sure if you'd have access to the points, right? Because you've preempted the request. Other than that, well, I actually can find a cons, a drawback instead of a positive side.
Right. That's what either.
For example, one drawback I can see is that, well, in the way I did it, this has no issues. But for example, if instead of doing this, I did this. Okay. Then I would have really severe, severe issues, because for example, in here we are reading once per second, right?
Yeah.
And in here, I am reading from the laser scan, I don't know how many messages per second, okay? And so what is going to happen, and even in here, I have a huge rate. So what is going to happen is when I publish to this in front wall, I'm going to publish at a faster rate than I'm probably that, like in here, I'm going to receive the messages probably at the same rate. I'm not sure what the queue size is, but what happens is this method is going at once per second, right? And so what is going to happen is, okay, at one point, these will be false because, for example, we get to the edge and it sees that there is a wall. But imagine that the robot continues walking, continues moving, and that the object that was in front of him gets out of its way. At that point, since we are publishing at a faster rate, and this is going at a slower rate, we would never see the message. We could never see the message because we would have a data race.
Right.
So we have two different callbacks, reading and writing to the same shared variable.
Yeah.
What I thought was to add a mutex, but then adding a lock to a variable would change the rate at that, for example, these callback is able to operate, because it needs to wait for the walk to be free,
Right.
and this has a walk and stuff like that. And I saw something, I tried to see something online on joining callbacks. Not sure what it was. It was like a method from ROS that allowed you to join two different callbacks and have both messages in a single callback at the same frequency, and then it wouldn't have this issue. But in this case, this callback is an action callback. And this is a callback from a subscription, right? So
Right.
we can join them both. So one of the drawbacks is that race. Well, I'm not sure if it is the best practice, but for me, it felt like it was a good practice.
No, yeah, it
Like not to tell that the goal was canceled. Well, we found a wall, but
right, and you can build on top of that to kind of let the system know that, you know, the action was completed, but, you know, not fully, because
yeah,
you now have that found wall topic.
the point, yeah, the point of the action was just to get the points and
Yeah.
get the total travel.
Right.
If it finished it earlier, well,
Doesn't matter. Yeah,
it doesn't matter. We
still want the result.
The list of points.
Yeah,
right?
I think that's a good idea. And just the other question I wanted to ask you is, you mentioned that the rotation was not that exact, and you did it with time, right? Just with a time. What other ways do you think there could be, so you can sort of make that more precise? And I'm not just talking about, like, you know, making a perfect square, but in when you're working with mobile bases, there are a lot of ways. There are a lot of times when you need to know that you actually rotated a certain amount. So what other ways do you think that could be implemented, so you know each time, you know, no matter which angular velocity you're sending it, that it'll do a certain angle?
Yeah, to be honest, I'm not really sure how I would do different, because we had one of the exercises was with BB8, and BB8 had like almost the exact same issue here. It had more issues because it had the momentum, because it was a ball, and so it had the momentum when it was walking and even when stopping. To be honest, I've tried to search for other ways to rotate, and even other ways to, for example, walk a certain amount of like for
Forward.
example, yeah, from moving forward, because in here I'm doing the exact same thing I'm doing with the rotation. I'm like, okay, I need to go 6, but then I'm relying on the frequency to ensure that I'm moving the amount that I want. And this is obviously the same issue. I think at the time I saw that there was some solutions where you use the library which gave you the position of, for example, to solve this issue, I saw that there was something that gave you like the position of the robot. So that was able to give you the position of the robot. So what you could do is simply like, okay, now if I can receive messages about the position of the robot, and I know I need to move 6 meters, so I'll just have it move until the difference between
Exactly.
it is now and when it's then. Not sure if that also provides information about the robot's Z position, like this.
Well, you could use
Where
the
is it?
odometry for that, no?
Yeah. So
Just
and do the exact same
with
thing
the
as
odometry,
the
exactly.
before.
Yeah, yeah, that's another way. Or I remember one of our students looked at a range of the laser scan and waited until it repeated itself, like 90 degrees later. So when the laser scan
Oh
kind
yeah,
of shifts by that amount, okay, assuming nothing is changing in the environment,
that's really smart.
that was just another way. But yeah, that you said, using the position and the angular, and check that continuously. That way you could also do it. But I mean, other than that, I just want to say that it's a great job. Really clear. Really, I like that the fact that you used classes, which is really important for when your programs start getting more and
Yeah.
more complicated. And I mean, other than that, everything else is pretty clear. So, congratulations. It's a really, really effective way of doing this project.
Thank you, Ricardo.
So let me just, if you don't mind, stop sharing your screen so we can
Okay.
hear us say goodbye. Let me make sure everything's good over here. Okay, yeah. So, thank you everyone for watching. You now saw what Paulo did with this project, and this could be you. And this is just a way to have you practice with real robots. Like you saw, there are some things that happen when you move from the simulation to the real robot. But this is just something we provide for you to do practice and just build on top of this. And I just want to say to Paulo, thank you very much, and I hope to see more projects coming from your side.
Oh yeah, sure. We probably within a month.
All right. Well, that's it from us, you guys. So thank you very much, Paulo, and then thank you to everyone that watched. And make sure you catch us next time. We have another presentation tomorrow, so we'll be there. We'll be here showing what students have learned. So thank you, guys, and have a good day. Bye-bye. Okay, that's it.